All right. Good morning, good afternoon, good evening to everybody. And thank you for joining us today. We got a great session today. We are going to have one of our favorite customers for many reasons, join us today and talk about their use of CockroachDB. I'm so happy to have DoorDash on the call today. And we're going to talk about just future-proofing, scale-out systems, a lot of the stuff that's been going on at DoorDash over the past, I guess, almost a year now. Since we've started working with that team. So, but first off, a little bit of housekeeping before we get started. Before we get asked, yes, definitely a recording of the event will be available. So we'll get that out to everybody. We try to do this immediately after the event. It should be up on our YouTube channel relatively quickly. But we may have to edit and do some things, so we'll get it up there as much as we can. There is a QA panel. There is also a chat. I am joined by a couple people here from Cockroach Labs, and there's several of us that are just actually as attendees as well. We are happy to answer all questions in both those channels, and I know JP will be giving out a hat. I think we have a bunch of them to some of the best questions that we get, or some of the most prolific communicators in the chat. We've had some really great success with that in the past. So with that, I'll just give a quick overview of the session. So if, I don't know if my guests can join me, Sean and Tim and Daniel. So today, this is, people like to have me say, is this a beginner, intermediate, advanced? I'm calling this intermediate because, well, I know our guests pretty well, and we can stay high up, but I know Sean's going to get into the weeds a little bit in some of this stuff, and I'm excited about that. And so today we're just going to talk about DoorDash, some of the stuff that's going on there from a data point of view, and some of their experience with Cockroach Database with that team. And I am joined. First of all, let me just introduce my team, the Cockroach team. So Daniel Holt, who's a solution engineer out of my favorite Welshman out of the UK, and so it's a little dark there, Daniel. You look good though. Tim Vale, who's on every one of these with me. Thank you for joining, Tim. As always.
Glad to be here, Jim.
You bet, buddy. And so Tim will interject and join in, and then, also be engaged in chat, helping out with questions and whatnot. But, our guest of honor is Sean, who is I'm sorry, Sean. I love that everybody's a software engineer over at DoorDash. But Sean from DoorDash is joining us. And Sean has been an incredible champion of ours, both inside DoorDash and I think externally as well. And on behalf of the entire Cockroach Labs team, Sean, before we even get started, I mean, thank you so much. Like, not just for, believing in us, seeing this technology, the architecture, and like technically what we've done, but just being a supporter of us. And we really think of you as kind of an extended part of the team. The feedback you've given us, everything you've done for us, we're just wildly thankful for all that. But most of all, thank you for joining me today, because this is just the best of all these things. So welcome, Sean.
You bet. Thanks. I promise all the feedback has been all up and up.
Exactly, right? So Sean, just before we get started, can you just let the audience know kind of what your role is at DoorDash and kind of what's your purview?
Yeah, I work in the infrastructure department, specifically core infrastructure. We're responsible for largely keeping the infrastructure up so that our teams and applications can run on our platform. Mostly focused on multi-region, or the technologies and strategies that kind of help us improve our multi-region story. So a lot of storage and a lot of traffic, CDN.
So a lot of network, a lot of storage. Do you focus?
Top and bottom.
It's not, you don't have an exclusive focus on databases. You're kind of seeing this from lots of different angles, right?
Yeah. When I first came to DoorDash, my focus was largely on the parts that would help enable the long-term growth of the company, which included a lot of scalability and robustness hardening strategies.
Yeah.
So yeah.
Yeah. Well, growth of the company has been phenomenal. I think, congratulations on such a successful year last year. It was great to watch everything. I mean, it was really exciting for us because I think we have a little bit of insight into kind of, what DoorDash really is. I mean, I think a lot of us think of DoorDash as, well, there's a guy who shows up at my door and he gives me some Thai food and it's awesome, right? But I think DoorDash is much bigger than that, right? I mean, it's more of a platform more than anything, Sean, just to kind of level set with everybody. It's not just food delivery, right?
No, it's not.
Uh-oh.
There we go. Okay.
Here we go.
VPN. Let me turn that off. So yeah, it's very much not just a food delivery service. We are a, last mile logistics. I remember when for me, I had this kind of like awestruck moment. Not whatever, but I thought that I understood it, right? And then within, a week or two, I was very much kind of humbled by the scope and scale of some of the stuff that we were working on. So very much not just food delivery. Last mile logistics is certainly the business.
Yeah, and I think that's exactly what I saw when you all filed and came out last year. I guess I didn't realize how big the vision is, right? And I think it's really driven by a lot of what you and the team are doing in IT, right? I mean, this is a technology play, right? More than anything.
I need to probably review some of our talking points a little bit more closely, but I definitely don't think of us as an IT company or a technology company. I think of us very much as a logistics company. That we're leveraging technology a pile, right? But we're very much a logistics company.
That's right. Well, it's funny. I think a lot of companies are, I guess let me alter what I was said. And it's more of like, it's driving a lot of the strategy, or it's helping kind of deliver on that strategy. I mean, we talk about, the banks we work with, are they banking firms or are they IT companies at this point sometimes, right? Like they hire a lot of engineers, right?
It's easier for me maybe to talk about some other people in the world, like Capital One, for instance, is really kind of aggressive on the technology side of things. Not that other companies aren't, but like at Capital One in particular, I happen to know is very forward thinking with regards to their IT infrastructure and the like. And so, not to give them a shout out necessarily, but like there's some companies that are kind of, or Citadel's another good one, right? Like very focused on their technology as a competitive advantage. So
and we see it over and over and over and over again with our customers. I mean, it's traditionally, I think Cockroach has been a little bit of a kind of a intellectual kind of database. It was like this emerging thing that people are like, this is kind of cool, and I think those companies that bought into this earlier, they are kind of being driven, but I think it's becoming much more mainstream in terms of, because I think people really are trying to take advantage of the cloud and whatnot. So it's interesting times.
Yeah, I mean, if you're trying to eke out the last little bits of either performance or reliability, you're going to start to do things that are not traditional, right? Like, when you ran a 9-to-5 business, it was really common to, and I don't know, I'm sure a lot of people remember, you would have like your Saturday maintenance or your Friday night like whatever it was, where you could basically like pause the business to go do a thing and like do these massive invasive, changes or cutovers or whatever it was. And that was really common. Like I still run into that with a lot of the institutions that I work with, where like, we're sorry that our website's unavailable due to like, scheduled maintenance. And you're just kind of like, oh, okay. And businesses that want to get away from that, it takes effort and work to get away from that type of a mindset, because, the industry's kind of been accepting of that for 50 years and for good reason, right? Like crawl, walk, run. We didn't show up with this expectation of 100% overnight. So. Yeah,
and that's right. Like, everybody loves the database upgrade at 2 a.m. on Saturday. It's awesome. Love that. Love that so much. And and then we have come a long way. Like I remember, I was, when I was coding way back late 90s, it was like, when BEA Tuxedo came out, I was like, oh, this is the coolest thing I think I've ever seen. But like we are ages away from that. And I think today it's about on and available and scale. And these are, I don't know if we're eking those things out or if it's kind of becoming core requirements these days, right? I mean, it's kind of,
expectations have risen, I think, is probably the right thing. So it's become a requirement, but because like, everybody's just making these incremental 1% improvements, day over day, for a long period of time. And eventually you end up getting there where you realize, hey, I'm in a situation where I feel like I'm so stable where I need to go and induce an outage to make sure that everything is working. Like, there's a lot that kind of, we're now to the point where you're almost doing, reverse uptime in order to provoke watching your system respond. So
right. And I think it's a bit of a paradigm shift for people too. I mean, when I first started, I was at CoreOS for a while, and I remember when I first got there, I was talking to, Phillips and Polvi about, Kubernetes. I just didn't get it. Like it took me a while because it was a paradigm shift. It's a completely different way of thinking. Right. And, when I found Cockroach and I met Spencer, I was literally in awe. I was like, oh my God, that has to happen. You know, it's Cockroach or somebody is going to happen. So Sean, how did you first find CockroachDB? When were you first exposed to it? And, you know, kind of what attracted you to it? I presume a lot of the same things I saw.
Yeah, I think it was 2015, 2016, like a coworker of mine at HashiCorp was like, hey, check out this Cockroach thing. Because we were interested, working specifically on RAFT at the time, and looked at what you guys were doing with regards to RAFT and you know, looking to see if you'd come up with anything interesting there to look into. And that was the first time that this really showed up on my radar. But the architecture at the time with regards to shards and ranges, shards, with regards to ranges, chunklets, whatever, tablets, whatever, and the way that all kind of like fans out, really resonated with me. And it stayed kind of in the back of my mind as like, you know, technology to keep in touch with. And so that's, you know, been 4 or 5 years now. So,
yeah, you know, when I first saw Cockroach, it was actually Polvey was on stage. Alex Polvey, who was the founder and the CEO of CoreOS, he was on stage with Spencer, and it was at OpenStack Summit. And Brian, oh my God, I forget Brian's last name. They showed Cockroach. They showed Kubernetes failing. Like they would rip down pods, and Kubernetes would heal, and the database would have this little blip of like, okay, there was this little moment, and I was like, oh my God, that's so cool. And you know, do you run a database on the side of that world in an orchestrated or just on it, right? And that was my aha moment. It was pretty cool. So, so you know, actually, I love that there was the very first question, as always, we get this a lot, is like, what's with this name, Cockroach? And you know, so it's funny, you know, the story, you know, actually Spencer, when he created the Git repository, he has a little bit of a dark humor. You know, he and Peter, who are the founders of this company, Peter Mattis, they also actually created GIMP. If anybody is familiar with GIMP, which is open source manipulation tool, they named it GIMP again. I don't know if you've all seen Reservoir Dogs, but there's the other one.
Pulp Fiction.
Yeah, it's Pulp Fiction. Yeah. And Cockroach, basically, he's living in New York. It was like the resilient database, right? Let me ask you though, Sean. You know, using and introducing a database like CockroachDB in a place like DoorDash, was there any kind of ripple or kind of pushback on the name of us, or you know, I mean?
Oh yeah.
Yeah.
yes. I got probably the first reaction that a lot of people get is not necessarily a positive one, and because of exactly that, like I got YouTube videos sent to me from people talking about how cockroaches can survive being drowned, and like, you know, going through blenders and all like, you know, cockroach v, you know, mantis and all kinds of stuff. And I was just like, yeah, I understand. And it's really kind of like the way that I talk about it is like nuclear winter of like, you know, it just kind of survives and keeps ticking. You know, it may go into hiding for a bit, but comes out and like it's a resilient bug. But it's, you know, it carries a lot of baggage with it as a name.
A little bit.
We internally we call it CRDB.
I just, you know, it's funny. It's CockroachDB. I like saying Cockroach. You know, by Cockroach database. By the way, our onboarding process, you know, Chelsea, who does a phenomenal job here, we actually call that molting. Funny enough, we're all roachers internally, so you know, we embrace the thing. I mean, why not, right? Yeah. So it works out. So
all good. Yeah.
So that said, you know, Sean, I want to get into like a little bit of the usage of what's going on at DoorDash. And so, you know, how would you characterize the, you know, the usage of CockroachDB? Real high level general question to start at DoorDash.
Yeah, I think high level is, you know, we have applications that were written for transaction semantics, and they make natural candidates for potentially for moving onto or being developed against Cockroach. So that's one thing. There's definitely the promise of being able to move data between regions that's really, you know, appealing, and so it's a forward-thinking decision for a lot of teams. So yeah, as a company, we grew up on Django, which is Django and Postgres, and so, you know, a lot of the talent that we have on staff is accustomed to working with Postgres, and so the Cockroach provides us with this, you know, wire compatible, like very similar semantic style of database. So there's a lot of parity there, and it works well for a lot of folks. So from a training perspective, or from a just a mental familiarity perspective, it works. It doesn't feel like something too entirely brand new,
Right.
But I'm going to put a couple of asterisks and caveats and whatever. Yeah, it's not exactly the same, but yeah.
Yeah, let's you and I spoke about that a little bit over the past week, and so I want to come back to that point because is this Postgres or not? Yeah, we're wire compatible, similar syntax, but like I think there's a little bit of this paradigm shift, and let's come back to that for a second.
Totally.
I want to come back to you mentioned kind of workloads that you guys are using this for and kind of the requirements of those, and then you also talked about multi-region. I presume. The workload benefits like the scale and resilience kind of came in before kind of this multi-region capability. Is that kind of where you guys started with Cockroach, or was it more like, hey, look, we're going to be everywhere. We should choose a database that's going to do this sort of thing?
Yeah. So it's really tempting to want to jump to kind of the end state for what you can do with Cockroach. And if you're developing something where you don't have a fire hose of traffic already, that may actually be a really smart way to go, because then you're designing with the speed of light constraints already in place. So you don't have to kind of shock the system by introducing, 50 milliseconds worth of lag at times because you're trying to do a quorum right across regions, let's say. No, in our case, it was very much about how do we handle and how do we grow transactional scale within a particular region.
Right.
And, there's only so much hardware that you can only scale vertically so much, right? Like at some point in time, you're just like 96 cores is 96 cores, and 144 cores may come out at some point in time, but it's not here today. So we're not going up, we're going out. And that requires a change of software in order to support going out, right?
Right.
So Cockroach, provides that effectively for us. So.
And I mean, Sean, I love the scale out versus up kind of conversation too, because I mean, there's efficiencies in scale out as well over the scale up, correct? I mean, there's huge, massive efficiencies, right?
Yeah. Right. But at the same time, like one of the things that we ran into early on was we were like, well, we're going to scale out. And then once we scale out, we'll begin to scale up, right? Because you scale out and you're going to end up with lots of small stones make small splashes, big stones make big splashes. We're going to scale wide with small stones. And at some point in time, also you realize like there is overhead to going wide. And so you want to scale up, and there's kind of a sweet spot in the way that you have to navigate that set of trade-offs.
Yeah, it's a balance, I think. And I think it's different for every company, but almost every workload as well, because I think the requirements become the key. Like that's what's going to depict and determine your balance and what you want to do. I think that's the key thing there. And and it's funny, I think, we think about scale out and we think about kind of these NoSQL type databases. That's for reads. We're talking about scale reads and writes for you all, and transactions as well. I mean, transactions was a key part of this decision as well, correct?
Yeah, it definitely was. The fact that we could have serializable, style isolation is definitely a benefit, because that's not something that we would have to then go and potentially go and detect, right? We don't have to run like a read committed consistency checker to go and make sure that there's, the unexpected variants in our workflow are addressed, right? So yeah, it's definitely a benefit. It's not one that we're using too aggressively this second. But that's just because of where we are with onboarding of a lot of applications. So,
right. Yeah. And I think it's somebody's got to call, right? So, yeah, it's all good, dude. And I think that's one of those things too. I don't think developers actually understand isolation levels. I know that's a very, very broad statement. I don't want to upset anybody, but in general, come on, right? Like, do developers really get isolation levels?
It's not a part of the normal development workflow where like there's no muscle memory around people writing their database software to assume that there's retriable transactions. I remember I remember enabling serializable in a prior life, and all of a sudden serializable errors started to be returned to applications, and they're like, "What is this?" And I'm like, "You read from a row that was just modified in a different transaction. You're going to get a retriable error. Like the database can't resolve this for you." And they're like, "Well, why not?" I'm like, okay. So, but like, it's not a hard thing to go and deal with. You just have to wrap a transaction or like wrap your database workload inside of a retriable block and retry it. And, you kind of, may do some duplicate work, but you're doing duplicate work for correctness sake, as opposed to duplicate work for duplicate work's sake. Right. Like the database told you have to do this because the result that you had from your first attempt was going to be wrong, right? Just objectively wrong. So do it again. It's okay.
Yeah, I mean, try catch was invented for a reason, and we do these things. I mean, it's it's there for. I remember when I was like, I don't want to deal with any of this crap. Can I just make the thing work? You know what I mean? And yeah, unit test what? I'm sorry. I was a horrible developer. That's why I ended up being
it's really hard to unit test for some of this stuff, right? So like you don't normally see some of this stuff until you have like conflicting transactions in production. And then you're like, I got an error. Now I have to go and handle it. And so like it's, you know, it's not a common thing. You can go and add libraries and add the appropriate abstractions. And I think that as an industry, we're starting to become more aware of some of that stuff. But we're not quite there yet where it's common, right? But it's becoming more common. So it's good.
Yeah, I mean, to the extent that you could talk about that sort of thing as well, Sean, you know, I don't want to, you know, I know there's a lot of stuff that happens in DoorDash. It's really kind of, it's a phenomenal business. And, you know, how much is the team of developers who are interacting with Cockroach, how comfortable have they become with this kind of like, yeah, oh gosh, I got to wrapper this thing with retry logic and that sort of stuff? Or is this just something that's kind of, you know, given?
The way that this normally happens is somebody goes and pushes a new feature, pushes a thing, and they start seeing their error count go up, and they're like, hey, what's this? And I'm like, oh, that's a serializable. Go, be like, here, read this page on retriable, you know, errors that you may get back. You clearly weren't going to run into it in development because you just don't have enough load to go and have serializable, or where you're not going to get like a retriable error. It's not just serializable that you'll get a couple of these, like there's lease transfers and a few others that'll cause some of this from explicit transactions. And so like, you just need to go and wrap your code with the try block, or, you know, try, catch, repeat, whatever, like it depends on your language. It's normally like a 30-minute to an hour conversation. But yeah, it's a thing.
Yeah, and I think people eventually get used to it is what ends up happening. So let's shift a little bit into kind of the multi-region thing. And, you know, you brought up this whole concept of the speed of light. The speed of light ain't no joke. You know, I know one of our engineering leads here, Andy Kimball, is always kind of like, well, our ultimate competition is the speed of light. That's what I think of at Cockroach, because some of the stuff we're doing is just phenomenal. And, you know, I think that's it's not something to be ignored, I think, in some of these workloads, especially when it comes to writes. Correct. I mean, like, I think getting scale out reads across the planet, we've done that, you know, I think, you know, but writing data and across multiple regions. I mean, how much of the workloads, or what kind of workloads could you talk about that are kind of doing multi-region, or at least just like, what are the challenges you all had, Sean, as you guys started to deploy like that?
Yeah, we're not, I think we're doing everything for Cockroach right now. We're deploying inside of a single region right now. Okay. And this is very much a you know, it's a crawl, walk, run kind of approach. Like, you know, planes moving, don't want to do too much here to, like, you know, where you're going to shock the system effectively. But multi-region stuff is, and enabling multi-region writes, that's going to be, you know, is in and of itself is going to be a big shock, right? So if you go from, let's say, Postgres, where you're doing a memory committed type operation, you've got your latency and you know, hundreds of microseconds kind of a thing, because it's on a single server. You're going to move to a distributed system that's going to do a network quorum write. And so then you're looking at, like, you know, we've got P99s for some workloads of, like, you know, low milliseconds of, like, you know, 1 to 4, depending on kind of like the size of the payload. 4 is a pretty, like, I've got a workload in mind that I've just spent a lot of time with recently. And it's at 4.1 milliseconds for its P99 work write latency. On, you know, 200,000 rows a second or something like that of ingest. So it's pretty, you know, pretty sizable in ingest rate. And but that's all local, right? Like, that's within a region. Now, if you go and if we went and took that type of a workload and we went and spread that over a couple of regions, right? Like, you know, this is where the topology becomes really important, and we're not skinning that cat right this second, because this is going to come as a big shock to a lot of folks. Is like, how do you handle some of the back pressure that's going to come from, you know, doing a multi-region quorum write? So, like, imagine you've got, let's just stick with 3 replicas for now. And if you've got all 3 of them in one region, so you've got them all in, like, you know, in Northern California, right? You got 3 writes happening in Silicon Valley. And then you're going to take one of those and you're going to move it to the next nearest Amazon data center, right? Which would be US West 2. And you're going to go 20 milliseconds to go and get that last potential write, right? In order to have some type of a quorum write. And going from 1 millisecond to 20 milliseconds, somebody's going to have to pay that back pressure, right? So you're going to increase your connection count. You're going to have a lot more, you know, work in flight that's uncommitted, that is in the process of being committed. And somebody has to absorb that, and you have to go through that exercise. And so you need to get to a stable point with regards to adoption before you can go and say, all right, now we're going to go and enable this, a second region for your database so that you can have the availability promises potentially there. Or like that actually won't work because now you're going to be split brain between two regions. So maybe it's going to be US West 1, US West 2, and US East 2, right? But what does that topology look like? And so it becomes, there's definitely challenges there. And if you introduce US East 2 into this, like that's a 50, 60 millisecond latency there. So crawl, walk, run, don't jump to the finish line unless you're growing your workload at the same times, I think is probably the piece of advice I would give there. And that's why we're doing it. And I think, one region per cluster right now. Yeah,
and that's right, Sean. And I think, I think we first met you, it's like a year ago this week or something, I think, right? And so like, I mean, something like that. So, and so, right? As lucky us, I guess. No, seriously, lucky us. But I think, the journey that DoorDash has taken is exactly right. And we see this time and time again with the customers. It's like, yes, crawl, walk, run. Like, yes, there is a vision. Can it get us there? Yes. Yeah. But it comes back to something that you and I were talking about last week. And it was, just this concept of Postgres, but wait, we are like, look at, this is a logical database, but I think when you deploy Cockroach and when you think about queries and when you think about how the database is going to work, there is a physical model as well. So it's not just this logical model that we're all used to, which still works, and the syntax and everything, but there is this physical thing. And this is kind of exactly what we're talking about, right? And can you just talk through that? Yeah.
So this workload that I was talking about actually just a second ago, like we had a really fun set of aha moments. And one of them was, and this is almost everything you could hope for, right? Developer went and read the documentation, read it from end to end, has experience with multiple different databases, said, hey, this is like, what I used to do in Postgres. In this particular case, they're trying to optimize writes. So I'm going to go and batch everything. And this is what I would do in Postgres. I do begin, batched insert, commit. Cockroach read the docs, says exactly, do the exact same thing, multi-value insert. I did it and like not feeling the love right now. So we went and dug into it and we're kind of like scratching our head and we're like, hey, he's doing the right thing from an application perspective. And that really like, you're kind of like, okay, like, you're trying to figure out like, oh, maybe you're not batching the data right. Or like, what's the, how's the driver, passing along its data, or like, maybe is it doing something wrong inside the app? And all of a sudden you go, oh, wait a second. The table that you're inserting into has a primary key and it's got secondary indexes. And all of a sudden, like this massive light bulb collectively goes off for everyone in the room. And you go, the secondary indexes are going to take what was going to be a batched insert for a single table in a single range. And then when you do that secondary index, it's going to shred that data and send it to every node in the cluster. So that batch size of 1,000 is not, that is not the droid you're looking for. And you get to this really counterintuitive point of view, which is absolutely correct, which is doing one row at a time may actually be the right thing if you're trying to do bulk inserts for tables that have secondary indexes. That said, like if you have no secondary indexes, batched inserts on a single table are, especially when you have aligned all your data along that primary key, that's, man, you're just gonna rip. It's great. But it's really counterintuitive. And so like, this is probably the biggest takeaway for me, for other engineers, for everybody that I talk to, is just because it's Postgres wire compatible doesn't mean that all of your assumptions about Postgres are valid, right? You need to check most of those, a lot of them, at the door, and go through and do a schema evaluation, indexing, query optimizations, et cetera, specific for the Cockroach database, because you can move your application, but there's going to be some period of adoption there where you're going to have to go through and think critically about what's this going to do on a distributed database, right? Like there's rigor to that, and you have to go through that exercise to level up your application, like just period.
Yeah.
And it's sometimes not counterintuitive. And for a lot of folks, you'll either be reminded of this routinely, or it's just the first time ever, and you're going to get indoctrinated into the way distributed systems and distributed databases work. So
Yeah, I think it's just this journey that everybody has to go through to distributed systems, and no matter
Yep.
what you're doing with them, I mean, if you're going to talk about scale, you're talking about resilience, this multi-region, distributing transactions. I don't care even if it's stateless, like you're still, there's a paradigm shift, and it's like this layer of the physical location of where things are happening creates it's a rub, right?
It's a convenient, friendly, familiar abstraction. You are talking to a distributed database. This is not the thing that you thought you were showing up with in the common case, right? Like if you've only got like a 9-node cluster with like fewer than 1,000 QPS, you'll be just fine. Doesn't matter. Like generally speaking, doesn't really matter. But like when you start getting to higher and higher volumes, you really start realizing and appreciating the fact that you're actually talking with a distributed system, and it's going to behave like a distributed system, even though it's Postgres.
Yeah, and you're gonna wrap a whole lot of great capabilities out of that, and you're gonna get a lot out of it.
There's trade-offs, right?
You need to know how to drive that thing, right? Like it's like
So let me interject
Tim,
here,
sorry,
because it's great. First of all, the crowd we have today is incredibly active. I don't think I've ever had to type as fast as I'm typing now. Dan and I are like going nuts answering questions, but one keeps coming up, and I thought this is good. There's a question about CAP theorem, right? And Dan and I have been busy explaining kind of where we sit on the CAP theorem. We're kind of a CP system, but there's this question like, well, what is CAP theorem? And since you guys are talking about distributed transactions and distributed databases, I thought maybe now would be a good time just to, hey, what the heck is CAP? And why or should you care? And I was going to throw this to Sean because Sean's the guest of honor, but I don't want to put you on the spot if you don't want to talk about CAP theorem.
I'm more of a marketing guy answering this anyway, Tim.
Yeah, I mean, we certainly don't want Jim doing this. So, but I thought it was nice because I think we got a mix of people on this call that are kind of brand new to Cockroach, certainly distributed systems. Anyway, I thought now might be a good time to talk about it.
Yeah, it's fine. I actually have not had to think about it. It's funny, like even though drive, run, operate this, like you don't really think much about CAP. You kind of begin to settle into the way that this particular database works, but without having to, refresh some of it. So a CAP is consistent database, available or partition tolerant. I think that's what.
That's right.
So Cockroach is a CP database. It's consistent, which means that it will return the right answer. It's partition tolerant, which means that you can lose some percentage of your nodes. It is not what's an AP style database, right? Where you can have a lot of nodes go potentially offline, and it will return an eventually consistent result as effectively like the end result of an AP style database. But you may get some incorrect or eventually consistent results. And so what that means in the case of Cockroach is every single range. So you have a table, and that table is broken down into a bunch of ranges. A range is 512 megabytes by default. And so if you're used to kind of like a Postgres table where you have these 1 gigabyte file extents, so every 1 gigabyte it goes and appends another extent or Oracle extent. Cockroach does something kind of similar. They're called ranges. And each one of these ranges, though, as opposed to it being resident on a single database or store or something like that, it is kind of spread out and distributed across every node. And then every range is its own unique RAFT quorum. And so this is one of the reasons from an architecture perspective I like it, is that means that you've got, if you got a really big table, you have lots and lots and lots of RAFT quorums that are happening effectively between all of these different these replicas of these ranges. So RAFT, though, requires an odd number of voters effectively. So if you've got a range, then it's going to have 3 replicas. So that means that data is going to exist on 3 separate servers with a replica of 3, replication factor of 3. And those 3 nodes will vote to make sure that only one of those replicas has the lease for and is the leader as a result. And so all rights will go to the leaseholder. And
Sean,
the CP database means that all reads and writes will go to that one replica by default. There's follow reads and other things. But then writes, you need to wait for at least, I forget off the top of my head, but like at least in this case, it's 2 with replica factor. You have to get acknowledgement back from 2 nodes. In this case, yourself and somebody else. And then you're able to acknowledge the write and then return the result back to the client. So
Yeah.
I mean, this guy's got it. He's got it down.
I know, right? Better than
Perfect
you
answer.
describe it, Tim.
I know. Give him a gold star. Somebody give him a
So-
DoorDash gift certificate.
I better, to be frank, I better know this at this point.
Yeah.
But yeah.
But I think that's one of those key things, Sean. I mean, as you get into distributed systems, understanding what the CAP theorem is. Yeah, you haven't thought about it in a while because it's kind of part of you. You know what I mean? But you knew what it was. I think this is one of those things I had to figure out too. Understanding RAFT and how that works, it meant a lot to me, and that really helped me start to understand distributed systems, because it's distributed consensus. That's what it's a distributed consensus protocol. And if you think about those words, right, distributed and consensus, I mean, there's a whole lot in there, right?
Right. And that's largely where some of the resilience comes from. Like,
right.
Something that's, if you've got a big table and you've spread your workload evenly, then something that's happening for a small set of ranges is only going to affect a small set of ranges.
That's right.
And that's basically what you want. It means that 90% of your data was online and available in some capacity, right? Or from a performance perspective, any kind of compaction activity is limited to just that one range, which means that, of your 100% of your user base or whatever your internal customers, only some subset, some very small percentage of that is being impacted because of some type of database activity. That's happening at machine time, not human time, where it's handled by the cluster, by the software, and nobody's kind of involved in maybe moving workloads off of those nodes because you've broken apart the problem into 512 megabyte chunks, right? That's a really approachable problem for computers to go and, self-serve, self-assemble, or reassemble in a lot of cases.
Well, we come back to this every single time. It's a paradigm shift. You don't have to actually architect for resilience anymore. You can actually code the system to be resilient, right? And it's don't plan for dead time or plan for disaster. Work it into the way that you actually are, right?
Yeah.
Don't have to plan for scale in 2 years. Just work it into and I think that's what's changed over the past, I'd say 5 to 8 years in terms of modern software development, is these concepts are now kind of worked into the way that we actually do these things. And so, go on, Sean, sorry.
No, I was going to say that's exactly it.
Right.
We really didn't, nobody said, 10 years ago, hey, we should get to this destination. It really is kind of this iterative process. And
right.
You guys internally, from your guys' pedigree of doing F1 and Spanner, kind of needed to get there from a necessity perspective internally inside of Google, and externally externally as Cockroach, there's kind of this external demand and drive to go and get there. So.
Yeah.
Hey, Jim, I have another question, and you feel free to push me along here, but I was kind of throw this out to Sean as well. So we've gotten some chatter in the chat in the QA about stored procedures. Now, Cockroach does not today support stored procedures, which and we know. And there's some talk about how we may do that in the future. And if the same can be said about triggers as well. I am curious, whether this was something you encountered at DoorDash as you guys were thinking about adopting Cockroach. How did you handle it? What was the messaging? Or even
we made a feature request. I'll tell you exactly what happened. We made a feature request because our dominant use case for stored procedures was to go and update columns with an updated at value.
Mm-hmm.
And so we would use that, assign it to the value whenever there was any type of update to a Postgres row. And that was basically the dominant reason. We explained that reason, and you guys actually exposed an internal MVCC time clock to us, a RAFT time counter to us, CRDB internal MVCC timestamp or something like that. I forget what it is, RAFT timestamp. And we use that as our updated at for some of our applications. So we've worked around it. I don't know if workaround is hey, we have this use case and it's really important to us. But I think that's a perfectly acceptable answer. We leveraged you guys and said, here's our problem. This is what we needed. And you guys did it. And it showed it in the 20.2 release.
Yeah. And I think that's just, Sean, our customers are our greatest source of feature requests. And I think that's why Tim's bringing that up. We do get conversations about this, and there are ways to work through this. And we have a team of people who've been through this, and it's by working with companies that are doing amazing things in production like yourselves, we're learning as well. And I think it's a journey. I think the database is the bridge to get you there for sure. But I want to actually come back, Sean. You and I were talking through, and you showed me a couple of screenshots of some incidents and whatnot.
Yeah.
And I want to make sure we have time to actually walk through a couple of those, because I think it does show off some of the extra value that a distributed system can give to you from a database point of view, right?
Yeah, so a lot of these are actually for an upcoming lunch and learn that I was going to do with our engineering department. So like, I feel, it's a little embarrassing to be giving this publicly as opposed to like having gone through this internally, but bear with me.
I'm saving you time, Sean. We're saving you time, right? Like,
That's exactly it. So hold on a second. Let me make sure that I'm,
instead of doing it the 3 hours before that meeting, you're doing it like, before this one, it'll be better next time.
That's right. So I grabbed a couple of the screenshots out of one of our that I've been accumulating just because we've had some really neat success stories. And so one of them was we had a node that was scheduled for retirement, and great. So this graph, there's a lot going on in this particular graph. This was a smaller cluster. Let me see if I can do this here. Annotate.
And this is the CockroachDB.
This is the Cockroach interface.
Yeah.
So there's a couple things that are worth pointing out here. P99 latency, right? This one's 4.1. That's a really common number. Like if you've got for our environment, for the way that we've deployed everything, for a whole lot of reasons, 4.1 comes up all the time as a P99 for us. And that basically means that we've done it right. But it's only it's a pretty small cluster. In this case, it's a 9 node cluster by default. And it's doing about 3,000 QPS. But this line here, this is really like kind of what happened. So replicas per node went up, and that's because one of the nodes died, and that was the node that was pulled out of rotation and retired. And so what happened there was the node was scheduled for retirement. It was pulled out of the NLB. Traffic to that node stopped coming in. We got paged, letting us know that the cluster node count went down. The system self-healed on its own. There wasn't any manual involvement. And like, for me, the reason we do this, right? Like operational excellence, rigor, whatever else, like we went through the process of, this particular team went through the process of moving their application to Cockroach explicitly because of this right here, right? We had a P99 of 4 milliseconds, and you can see here we had one node that peaked out with a P99 of like, just over 15 milliseconds. And it lasted for a couple minutes while the data was transferring around, and that was it, right? Like nobody got paged for like some catastrophic site failure. And you can see up here, there was no change in our QPS, right? Like this is the Cinderella story. This is the reason you do distributed databases, not because it's intellectually interesting. It is, you do it because at the end of the day, the outcome matters. And the outcome in this case was low impact to the business from a latency perspective and no impact to the business from a QPS perspective. Like that's the entire ballgame. Nothing else matters.
And Sean, I mean, the operational nightmare of dealing with this in the middle of the night as well ain't fun, man. Like, and so like avoiding that stuff actually is a big value, right? I mean, for the
everybody
team.
talks about bump in the middle of the night. It's never the bump of the night. It's always in the middle of peak. It's always in the middle of like,
even worse.
Like that's it's who cares about the bump in the middle of the night? Bump in the middle of the night, nobody affected, nobody. It's the bump in the middle of the day that matters.
Yeah. And just that nightmare that goes with that also avoided, right? Like, because then you're interrupt processing, everybody has to context switch into some other nightmare mode. Like it's just,
you're going to incident response mode. And so in this case, like we decommissioned the dead node to tell Cockroach this node's going away and it ain't ever coming back. And then as soon as we did that, the auto scaling group kicked in and launched a new instance. And you can see here, and this is, pretty small. This was a pretty read heavy, this particular database workload, very read heavy workload. Not a lot of data, and it, came back and, we're good. That was it. Like there was nothing to this in this particular case, because this was one of the first times actually that we'd experienced this particular failure mode. Asked the developer, we're like, hey, what did your application see? Like, like there's going to be some lesson learned here. What do we need to take away from this? And they went and searched through all their log files, and they didn't get a single, in this particular case, because the connection, their database connection pool was cycling through its connection, had disconnected and reconnected enough times that there was not a single log entry for any type of connection reset or transaction aborted or anything. It was like it was the Cinderella story. So it was really, really nice.
So almost if nobody had looked at this chart for maybe another hour, I guess
it would have aged out.
Nobody would have even known it happened, right? Like
we would have, because
I know
we disable the terminate process in the auto scaling group, so we have to manually kick at adding a new node.
Yeah.
So things will scale up on their own, but we never contract an auto scaling group without a person looking over things. So yeah. So that's one. That was a pretty neat, really neat, frankly, story. Like there's a lot of work that goes and a rigor with regards to adding Cockroach to an environment. Why do you do it? This is why you do it. So 70% uptimes suck. Like if somebody's ever exposes you to 70% uptime organization, you really want to run. Like that's something bad's going on there. But like you don't have to with this case. It's great. So this one's kind of a fun one. This is like a wall of traffic where like somebody just turned on the fire hose and you watch like the grass light up and you just kind of go, that's pretty neat to see. There's not an interesting story here so much as just like, it's just kind of cool to see.
Yeah, but this is just the database handling like a Black Friday type event. I'm not saying in the context of you, but I just, as like a bam, like, okay, scale, go.
This
right?
one was
like,
what, yeah, we turned on, this particular team turned on a workload and started diverting and teeing some traffic from one data processing system to a different data processing system.
Right.
And it just like, all the work showed up because there was just, a backlog of things to be chewed on because it was coming out of a queue. This is another neat one where we had gone through a scale up activity. And, you can see like all these leaseholders kind of like converging, and that's a pretty satisfying graph to watch everything kind of like normalize and hit equilibrium. I'm pretty happy about that one.
Sean, I really like your titles. So,
it's there's going to be like another like 20 years, like people are going to be like, what does that mean?
Don't worry about it.
Explain this, right? It'll live on forever. But yeah, like this is really like it's nice to see this type of replica per node. Like everything's kind of converging. This is a look at the node count, a much higher throughput. Not that much higher, but like it's a higher throughput, busier environment for this particular one. And like the way that we do upgrades, we don't do in-place upgrades of binaries. We actually add nodes and shoot nodes, and so we are like just refreshing and rolling new nodes constantly. In order to pick up operating system updates, in order to pick up binary updates, to defragment ZFS. We do it for a whole bunch of reasons, to throw SSDs back into the AWS pool, et cetera.
And Sean, are you doing rolling upgrades to the database too as well? Have you guys done that in a couple different instances?
Oh yeah. That's actually what this particular one was. This one was maybe this one wasn't, but yeah, routinely, very, very, this one was definitely a rolling upgrade. We were going from like a 22.3 to 22.4. Like this wasn't that long ago. It just happened to be pretty recent. So I was able to
Sean,
pull it,
I don't know if this is something you can comment on, but it's come up a couple times. Can you talk about like maybe some of the tooling you guys use to deploy Cockroach?
Really simple. Like you've got a distributed system. It's already complicated enough. So we use EC2, we use auto scaling group, and we use NLBs, and we wire everything up with infrastructure as code. So, and that's basically it. Like this is all, very internally driven. It's very easy to kind of like operate in that regard, but it took effort to get there. So it doesn't show up that way, but yeah, it's pretty self-explanatory for a lot of folks.
One of those things, you just talked about just putting a load balancer in front of it. And I think that's one of those things that gets lost with people. They're like, well, do I have to find the node where the data lives? No. Yeah. Ask any node as an endpoint, right? And I think that's such a key piece.
Yeah, so we use an NLB, we use an auto scaling group, because the auto scaling group will register the new nodes, the healthy nodes in the target group for the NLB. And so there's no service discovery really required for internal customers talking to Cockroach. The other thing that we really like is and we're about ready to begin deploying this, is exposing Cockroach as AWS private link endpoints, so that it's very much kind of database as a service internally in that regard. And people are just able to kind of consume a Postgres like endpoint.
Right. Yeah. Any endpoint, right? Read, write, do whatever you want it. So
yeah, doesn't matter.
Cool.
There's no writer endpoint. There's no reader endpoint. There's no analytics endpoint.
Endpoints.
It's here is your database. It's like
that's
behind
right.
this one thing.
Yeah.
Let's see. So if you let everything kind of settle, this is a different workload. This is 40 minutes, not a whole lot. It's nice to see this really small, like tight band right here in terms of the P99. Like this is nice.
This is so visually pleasing for me right now, Sean. I got to tell you, like, I'm just sorry, but like, we run a lot of internal workloads, and I see the same graphs, and that they're like visually to see this amount of traffic going through a Cockroach.
Yeah.
I'm sorry, just for everybody on the Cockroach team, it's like, thank you. This is kind of fun to see, actually. Yeah. For us, yeah.
It, like, I don't know. Nobody wants to talk, or not nobody, but like you don't normally get the opportunity to kind of expose some of this stuff.
Right.
So this one, this is the batched insert workload where we were, processing and ingesting some data here. And you can see, like, speaking of feedback, right? Like logarithmic graphs would be really nice, because then I could see the variance down here, even while I've got like these peaks up here while like a lease transfer happened. But like, I'm not going to write home about it. It's not a big deal, right? But there's a lot of volume that's coming through here. And it's nice to see. It's not to say that we've, had, when we onboard applications, we'll get into like, I don't call it dirty laundry, but like we've had to write some tooling for visualization stuff, right? And we've got we got a crack group of folks that plotted our data, right? QPS per range in this particular case. And this was a really kind of like a murky workload. And what we wanted to do was figure out kind of like what was going on and see the cluster. And so we're still trying to like reduce the cost of debugging some of these problems, and visualization and communicating the state of a cluster is a hard problem, right?
It is. Distributed
systems are hard on their own, but trying to present a UI on top of that to explain something concisely is very much it's almost a science in its own right. And we're trying to figure out what to do next. So one of our engineers, one of your engineers actually came up with this really, very convenient way of looking at things. And so you can kind of see here that we've got some hot ranges in this one cluster, and we were trying to figure out what was going on, which index, whatever. And we fixed it, that particular one, and we exposed the next thing. And so moving applications onto Cockroach is very much peeling an onion until you get to a steady state. And in this particular case, like we were peeling the onion, and as soon as we like fixed one thing, like you're like, oh, now we're down to the last one. And you can kind of like go through this iterative process and get there. So like this hot range is doing, roughly 6,000 QPS or something. So.
Yeah, I mean, visualization is a whole other level. I have a group of designers and engineers right now who are just saying amen to you right now. Right, Piyush? So anyway.
Yeah. And like, but there's lots of indicators in the data that it is there, right? Like, but you have to have some type of an understanding of what's going on, where and why. And so like in this particular case, like, average query per store, like something like, something's going on with whatever that blue line is, right? Like you've got this very healthy, steady state thing. And then that blue line, there's a story there. And there's always a story in every line, in every number, it seems like. And so this one particular one, I forget what it was that we did or fixed, but like you watch things like immediately come down. And then like, this graph here actually should be, this is really the story. This is the other kind of like story that you'll see frequently, is this guy right here. Is you kind of like go, huh? There's something hot there. So you can see that there's 3 nodes in particular that are doing a lot of hot write activity. And, it's not like they're all doing similar amounts of disk IO, but the size of the disk IO, I'm sorry, I'm getting this backwards. The read IO is different. And this was the system range actually that we were blowing up at that moment in time. But yeah, you see this, like whenever you see 3, if you've got a replication factor of 3 and you see 3 read operations or 3 write, that you've got like, a hot range, like, but now you have to go and find that, right? And then I think, let's see, here we go. Yeah, here we go. This is the one that I thought I was looking at. Where like, you've got a hot range, right? Like you're writing and you're blowing up. And this, I think this one was a secondary index. Speaking of like, assumptions to check at the door, try putting an index on a monotonic integer, or its close sibling, a created at index, right? If you don't realize that a created at index is going to behave exactly the same as a monotonic integer, then let me introduce you to this graph. And that, because like these things will show up and just, get in your face in a hurry.
Yeah.
I think the last one that I've got here. Yeah, this is another one that, like, just from a visualization, not all latencies are bad as they're expressed right now. And it's incredibly counterintuitive. And this will cause you to panic and freak out. And myself included routinely, we were doing like a huge amount of IO. We'd restarted a workload, and all of a sudden, the latency just went, took off through the roof, and we're like, ah! In this particular case, we did a truncate, whatever GCTTL hours ago, and all of the work was going through to reap all, like, some 5 terabytes worth of data. And that was impactful if you look at this graph. But if you go and look at the mean time for the SQL statements that were being run, their mean time didn't change meaningfully. But the service latency for the truncate gets the truncate, the GC operations shows up there as like some internal counter or something like that. And so it impacts this. And so like you have to be really careful about like teasing apart some of these numbers, because, it all gets homogenized in a distributed system frequently. And so, these are just some of the things that you have to work through as challenges right now. And, I'm expecting, looking forward to them getting better.
And I think this is just, as you mature with the database, these are the type of things that you then move on to, operationalize exactly. and have to deal with. Right. And I think that's where it gets really interesting. Look, I'm an aging punk, whatever, dude. I'm a Joy Division fan. So I'm thinking I'm going to grab some of these charts. I think, JP, we got to put these on a t-shirt and be like, you got a hot range or something. Like, I love, dude, I love it. So, but it just tells a good story, Sean. So, I mean, it's just really, really powerful stuff. I think the internal call is going to go well as well, by the way. So, but we gotta wrap up. It just, Sean, we talked about this, in prep, but like, if you were just kind of give people, going away, like, advice on either adoption or usage of Cockroach database, if you were wrapping that up into a point or two, what would you say that is?
Cockroach is a distributed database, right? Yeah. First and foremost, you can't forget that. Like, you are now changing from the physics of a single motherboard, dual socket, like, right. The physics of the problem are changing. Distributed database, like you've got order of magnitude more latency for a lot of things, right? And so, like, an insert is going to go from memory speed, wire speed to is going to go to network speed and network quorum speed, right? And so, assuming that you have everything in the same region, that network quorum speed is going to be measurable in, like, the low milliseconds, right? When you go to WAN replication, it's a different type of quorum. So that's one. And then the other one is just because you've got a really nice facade on top of a distributed database that is Postgres, doesn't mean that it is actually Postgres. The batching example comes to mind, where like you have somebody that read the documentation, knows what to expect, thinks that doing a begin insert commit or a begin update commit is the right thing to do, because getting a transaction inside of Postgres is the expensive thing. It's a whole other order of magnitude. You just want to use an implicit transaction, because then the database does things like, there's assumptions like this that you have to go and revalidate or refresh and realize that, like, it is just going to behave differently or be different. And once you make that transition, then you begin to reap the rewards. But like, if you're trying to force a distributed system into a single motherboard, server someplace, like, square peg round hole doesn't quite fit, but it doesn't mean that you have to go and rejigger your world to go and move to a distributed database either. So it's definitely a more pleasant way to get to a distributed system, I think.
Yeah. And, architecture and topology matter.
Yeah.
In distributed systems. The speed of light is no joke, guys. Like, it's like a thing. Like, it's but I think it's amazing that we're at that point technology where we're actually dealing with the speed of light now, which is it's just like we're getting to the physical limits of stuff. And I think this is, to me, it's the most exciting time ever, honestly.
Yep.
So
it's exciting times in database. I'm really happy to see that
it is.
Distributed databases are reaching the level of maturity where they're operationally usable in high workload environments outside of the Googles of the world, where like you've had 10 years and you know, a bajillion engineers. Like this is becoming almost commodity, so that you know, companies can begin to pick that up and begin using it and internalizing it, reaping the benefits.
Yeah. You know, Sean, we're seeing it too, and we're feeling it. I mean, day to day, Tim and I, and the rest of the team, you know, it's just amazing. And by working with customers like yourself, Sean, you've been phenomenal. Again, you know, your input, your you know, careful guidance. We have such great conversations with you across the board on lots of different things, and you know, it's just been really phenomenal. So again, I just wanted to, you know, thank you again for taking your time today. I know you're a busy person, and just on behalf of the entire team, thank you so much. And thank you on behalf of the audience. I hope it was very valuable. I think Daniel had to drop off at one point. Tim, I saw in the Slack back channel that his fingers hurt or something. So
it's been nuts. I mean, we tried our best. We left many unanswered.
So many questions.
Yeah.
Well, so there, I saw a lot of architecture questions. We do have a YouTube video that goes through the architecture of CockroachDB. Maybe we put that into the follow-up, because I think there are a lot of questions like, okay, great. What's a range? How does it work? The primary key thing, Sean, understanding those things is really critical. So getting the architecture talk, you know, I think that's a really good, I think we're going to be doing that webinar. I'm doing it, I think, in a couple of weeks or so. But we'll add that as follow-up here as part of our email back. But thank you everybody on our team for helping out here. Daniel, Tim, JP, awesome stuff. But thank you, Sean. That was phenomenal, dude. So I really, really appreciate it. And then thanks everybody for joining. With that, there is a survey after this. Please do take the survey. We love feedback. We continuously get comments that we kind of try to work into this whole thing. So a lot of the way that this thing has been shaped has been through comments of everybody who's attended. So on that behalf, should we all say goodbye? See y'all.
Bye.
Cheers.
Thanks, Sean.
Thank you.